So question 24 is like kind of a graph problem, and these kinds of questions are also pretty common on the AMC8, where like they give you some scenario and then they ask you, oh, like, let's say over time this guy's like running, but then like some things happen and you want to know like what you want to look at some parameter as a function of another parameter. Like in this case, we have this ship that's traveling from a point A to a point B on a semicircular path and is centered around at island X. And then it travels along a straight path from B to C. And we want to know what graph best shows the ship's distance from island X as it moves along its course. So the general strategy for graph problems is like you want to kind of look at the special cases. So, or in other words, you want to kind of divide the big problem into like smaller like sub problems, kind of, right? So we first have this like semicircular path from A to B. And then we have like this straight path from B to C. So let's try to like consider these two like paths like separately, right? So if we look at this blue path from A to B, it's like a semicircular path. And we know that like by definition, right? Since it's a semicircle, like if the ship is like here or here or here or here or any of those places, the distance from point X is always the same, right? Because they're all like radii of the semicircle. So that tells us for the beginning portion of the ship's journey, the distance from point X has to remain constant. So like that would like eliminate choice A, because clearly like here is going upward. That's like clearly wrong. And that also eliminates choice C, right? Because it's going like upward, but we need it to be flat. So that also doesn't work. So that leaves us with like choices like B, D, and E, because they all have like these like, horizontal lines at the beginning. Now what we have to do is we have to focus on like the red path now. So to look at the red path, notice that like now it's not going to like stay constant, right? Because it's no longer in a semicircular, or it's no longer in a circular path. So notice that like at the beginning, when the ship is traveling, when it's at point B, right? When the ship is at point B, you're going to have some distance. Now, as the ship is gradually traveling, it's going to kind of get closer and closer to point X. And the closest it's ever going to get to point X is like this perpendicular distance here, right? Like this point here, this red point there is like the closest the ship will ever get to point X. So let's call this point like Z or something, right? So from point B to point Z, the ship is like gradually getting closer and closer to point X. But when the ship reaches point Z and as it's leaving point Z and it's going to point C, it's like getting farther and farther away from point X. So we need the last portion of the graph to like initially get closer to point X, but later get farther from point X. So if we look at our answer choices, B looks like it does that, right? If we look at this portion, the distance from point X decreases in the beginning until some point, and then it starts increasing again, which is what we just described there. Choice D is not right, because like it does the opposite of what we just talked about. It gets farther away from point X until it gets closer to point X. That doesn't make any sense. And then choice E doesn't make sense either, because this portion of the graph is saying that the ship is always going to be getting farther and farther away from point X. So choices D and E can't be right. So by process of elimination, we find that like choice B has to be the right answer. Okay. Yeah, so this is a very common kind of question. And a lot of the times for these graph questions, they're very conceptual based. So like whenever you see a graph problem, most of the time you won't have to do very much calculation. Like if you have to do calculation, it will be very little calculation. And a lot of times just analyzing the special cases is like enough. And sometimes just splitting the problem into smaller sub problems is a good idea, right? So we like split the ship's journey. We first split it based on the semicircular journey and then like the straight path journey. And then we considered those two paths independently and looked at the graphs one by one. And we just did process of elimination basically. And we found our answer.